Climate change is real. The physics of greenhouse gases is well understood. Radiative forcing, carbon budgets, feedback loops, these are not speculative ideas. But alarmism is not the same thing as science. Alarmism is a mode of communication, not a data set. It emerges when uncertainty is flattened, timelines are compressed, and worst-case scenarios are presented as near certainties rather than boundary conditions. In this segment, we are not evaluating whether climate change exists. We are examining how climate risk is framed and how that framing can drift from technical assessment into narrative urgency. Alarmism arises when complex probabilistic systems are translated into emotionally absolute claims, point of no return, only X years left, irreversible collapse, without the accompanying statistical nuance that produce those phrases. Climate science operates on ensembles, confidence intervals, and scenario ranges. Public messaging, however, often demands clarity, immediacy, and moral force. This creates structural pressure to foreground the most extreme plausible outcomes, because those are the ones that motivate action, funding, policy alignment, and attention. Over time, this selection bias can become normalized, not because it is dishonest, but because it is effective. A key technical distinction is between hazard, risk, and impact. Hazard refers to the physical change itself, temperature increase, sea level rise, precipitation shifts. Risk combines hazard with exposure and vulnerability. Impact depends on adaptive capacity, technology, and governance. Alarmism frequently collapses all three into a single implied outcome, bypassing adaptation pathways and system resilience entirely. Another driver of alarmism is model misinterpretation. Climate models are tools for exploring futures, not predicting exact outcomes. They generate distributions, not destinies. When upper-bound scenarios, designed to test system stress, are repeatedly quoted without context, they can be mistaken for forecasts rather than stress tests. Over time, the public begins to perceive climate change as a singular, predetermined catastrophe rather than a spectrum of possible futures shaped by choices, responses, and constraints. There is also a temporal compression problem. Climate systems operate over decades and centuries, but political systems operate on election cycles, and media systems operate on hours. Alarmist framing bridges that mismatch by pulling distant risks into the emotional present. This is rhetorically powerful, but technically distorting, because it encourages the belief that nonlinear collapse is always imminent, even when the underlying science describes gradual trend shifts punctuated by localized shocks. Finally, alarmism tends to treat society as a passive object rather than an adaptive system. Humans respond. Markets shift. Infrastructure hardens. Technologies diffuse. None of these negate climate risk, but ignoring them exaggerates fragility while undercounting resilience. A technical discussion must hold both realities at once. This documentary begins here, not by denying climate change, but by questioning whether alarmist framing improves understanding or replaces it. To understand where alarmism begins, it helps to understand what climate models are actually built to do. Climate models are not crystal balls. They are large-scale numerical experiments designed to test how a coupled Earth system behaves under specific physical assumptions and boundary conditions. At their core, modern climate models, general circulation models, and Earth system models solve fundamental equations of fluid dynamics, thermodynamics, and radiative transfer across a discretized globe. The atmosphere, oceans, land surface, and cryosphere are divided into three-dimensional grid cells. Energy, momentum, moisture, and chemical constituents are exchanged between these cells over small time steps. This is computational physics, not storytelling. However, not all processes fit neatly into grid cells. Cloud formation, convection, aerosol interactions, vegetation response, and ice fracture occur at scales smaller than model resolution. These are handled through parameterization, statistical approximations informed by observation and theory. Parameterization is not a flaw, is a necessity, but it introduces uncertainty, and that uncertainty propagates forward in time. This is why no single model run is ever taken seriously on its own. Climate science relies on ensembles, dozens to hundreds of simulations run with slightly different initial conditions, parameter choices, or structural assumptions. The spread of outcomes is not noise, it is the signal. It tells researchers how sensitive the system is and where confidence is strong or weak. Alarmism often emerges when this ensemble logic is lost. The public is frequently shown one trajectory, often near the upper bound of plausible outcomes, without being shown the distribution it came from. What was meant as a stress test becomes perceived as a forecast. What was meant as a warning boundary becomes interpreted as inevitability. Another common misunderstanding involves emission scenarios. Scenarios are not predictions of human behavior. They are if-then storylines. If emissions follow this path, then the climate responds this way. Some scenarios assume rapid decarbonization, others assume stagnation or acceleration. Upper-end scenarios are intentionally pessimistic. They explore what happens if mitigation fails entirely. Their purpose is to test system limits, not to declare destiny. Yet once these scenarios leave the technical literature, their conditional nature is often stripped away. The if disappears. Only the then remains. This creates the impression that the most severe outcomes are not contingent but scheduled. Timescales are another source of distortion. Climate models are reliable at capturing long-term trends, not short-term fluctuations. They are not designed to say what happens next year or even in 5 years, but what statistical properties emerge over decades. When near-term extreme events are rhetorically linked directly to model outputs, the distinction between weather variability and climate trend is blurred, reinforcing a sense of constant emergency. It is also important to note what models explicitly do not include. Most models do not endogenously simulate political adaptation, market responses, technological breakthroughs, infrastructure hardening, or behavioral change. These are treated as external assumptions, not dynamic variables. As a result, model outputs often describe a world that absorbs damage but does not react, a physically coherent but socially static planet. This does not make the models wrong. It makes them incomplete by design. But when incomplete tools are treated as complete narratives, alarmism fills the gaps. The technical reality is quieter than the public story. Climate models do not say collapse is imminent. They say, under these assumptions, these ranges of outcomes become more likely. They speak in probabilities, not proclamations. Segment 2 ends with a crucial realization. Uncertainty is not ignorance, and severity is not certainty. Alarmism thrives when those distinctions dissolve. Few concepts have contributed more to climate alarmism than the idea of tipping points. The term is scientifically legitimate, but its popular interpretation often bears little resemblance to how it is used in Earth system science. In technical terms, a tipping point refers to a threshold in a nonlinear system where small incremental changes in forcing can trigger a qualitative shift in system state. This is not unique to climate. It appears in ecology, chemistry, economics, and engineering. What makes climate tipping points compelling and dangerous as rhetoric is that they suggest irreversibility, loss of control, and sudden collapse. But most climate tipping elements are not switches. They are gradual transitions with hysteresis, meaning they may take decades or centuries to unfold, and may not reverse on human timescales even if forcing is reduced. This is very different from the popular image of a sudden cliff edge. Take ice sheets as an example. Ice dynamics involve accumulation, basal lubrication, calving, and bedrock feedbacks. Some thresholds exist, particularly where grounding lines retreat into deeper basins. But even these processes operate over long durations. When alarmist narratives imply that ice sheet collapse could occur abruptly within a few years, they compress centuries of modeled change into an imagined moment of failure. The same applies to ocean circulation systems like the Atlantic meridional overturning circulation. Models explore weakening under warming scenarios, but collapse is neither predicted nor imminent in most simulations. The uncertainty lies in sensitivity and response time, not in the certainty of failure. Yet public discourse often treats possible weakening as inevitable shutdown. This pattern repeats across systems: permafrost carbon release, Amazon forest dieback, coral reef decline. Each involves feedbacks. Each involves thresholds. But none are binary in the way alarmist framing suggests. They degrade, fragment, and transform before they disappear, often unevenly and asynchronously across regions. Alarmism thrives on worst-case aggregation. Individual upper bound risks are stacked together as if they occur simultaneously, instantly, and without interaction delays. In reality, Earth systems are coupled but not synchronized. Feedbacks interact, but they do so across different spatial and temporal scales. Treating them as a single cascading failure exaggerates systemic fragility while ignoring damping mechanisms. There's also a linguistic problem. Scientific caution often uses phrases like "cannot be ruled out" or "low probability, high impact." These phrases are designed to flag uncertainty, not assert likelihood. But when translated into public discourse, they are frequently read as warnings of impending disaster. The conditional framing collapses into certainty. Another subtle contributor is the asymmetry of error tolerance. In climate communication, false negatives are treated as more dangerous than false positives. Missing a real risk is considered worse than overstating one. This is understandable from a precautionary perspective, but it incentivizes exaggeration over restraint. Over time, this skews narratives toward alarm even when probabilities remain low. Importantly, nonlinear does not mean unknowable, and tipping does not mean imminent. Most tipping elements are embedded within broad parameter ranges, not knife-edge thresholds. They represent zones of increased sensitivity, not points of instant collapse. Treating them otherwise turns legitimate scientific concern into deterministic fear. The deeper issue is that tipping points are often presented without contextual buffering, adaptation, intervention, regional variability, and time. When these buffers are excluded, the system appears brittle. When they are included, it appears stressed but responsive. Segment 3 leaves us with a core tension. Climate science must explore worst cases to understand system limits, but alarmism arises when those explorations are presented as foregone conclusions. The boundary between warning and prophecy is thin and often crossed unintentionally. Climate alarmism does not emerge from a single actor or intention. It is the product of interlocking institutional incentives, each rational in isolation, but collectively distorting when aligned in the same direction. Scientists, media organizations, policymakers, advocacy groups, and funding bodies operate under different constraints, but their feedback loops often reinforce urgency over nuance. At the research level, climate science is structured around competitive grant systems. Proposals must demonstrate relevance, significance, and impact. Framing a research question as addressing a severe or urgent risk increases its perceived importance. This does not require fabrication or exaggeration. It simply rewards the exploration of high-impact outcomes. Over time, this biases attention toward extreme scenarios, even when they are statistically marginal. Peer review further reinforces this pattern. Novelty and consequence are valued. A paper demonstrating stability or resilience under changing conditions is less likely to attract attention than one identifying a potential failure mode. As a result, the literature accumulates asymmetrically, with risks more visible than non-events and vulnerabilities more studied than robustness. When this literature moves into media space, the filtering becomes sharper. Journalism operates on scarcity of attention. Complex probability distributions do not survive headline compression. Statements such as increased likelihood under certain conditions are often simplified to scientists warn. The conditional language disappears, replaced by declarative framing. This is not necessarily malicious, it is structural. Media ecosystems also favor temporal immediacy. Long-term trends struggle to compete with breaking narratives. Alarmist framing accelerates relevance by making slow processes feel urgent. This creates a feedback loop. Urgency drives engagement, engagement drives coverage, coverage reinforces urgency. Policy institutions add another layer. Governments operate within electoral cycles and bureaucratic planning horizons. Long-term gradual risks are difficult to justify politically unless framed as immediate threats. Alarmist language becomes a tool for mobilization, used to overcome inertia, opposition, and public fatigue. Once adopted, it becomes difficult to walk back without appearing negligent. Advocacy organizations face similar pressures. Fundraising, membership growth, and visibility depend on emotional resonance. Messages that emphasize irreversible loss or existential danger outperform messages about incremental mitigation and adaptation. Over time, this selects for communication strategies that foreground catastrophe even when technical assessments remain probabilistic. None of this requires conspiracy. It emerges from aligned incentives, not coordination. Each actor responds to its own environment, but the combined effect is amplification. The most extreme interpretations propagate furthest, while cautious qualifiers are stripped away at each step. Another overlooked factor is reputational asymmetry. Publicly downplaying risk carries greater social and professional cost than overstating it. Scientists who emphasize uncertainty risk being mischaracterized as dismissive or obstructive. Institutions therefore err on the side of alarm, not because it is more accurate, but because it is safer. This asymmetry hardens narratives. Once an alarmist framing becomes dominant, dissenting nuance is treated as deviation rather than contribution. Debate narrows. Technical disagreement is recast as moral conflict. This further discourages complexity and reinforces binary thinking, action versus denial, urgency versus apathy. Segment 4 reveals that alarmism is not driven by bad data, but by good data moving through imperfect systems. Each translation step, from model to paper, from paper to headline, from headline to policy, filters out uncertainty while preserving urgency. The result is a public understanding of climate change that feels catastrophic, immediate, and singular, even when the underlying science describes gradual, distributed, and conditional risk. Alarmism does not only shape policy and media narratives, it reshapes human cognition. When climate change is framed as a permanent emergency, it interacts with psychological systems evolved for short-term threats, not decades-long risk management. The result is often the opposite of what alarmist messaging intends. Human risk perception is nonlinear. We respond strongly to immediate, visible dangers and poorly to abstract, slow-moving ones. Emergency framing attempts to override this limitation by collapsing long-term risk into a sense of present danger. Initially, this can increase attention and concern. Over time, however, it produces desensitization. When every year is described as the last chance, urgency loses meaning. This leads to risk fatigue, a psychological state in which individuals disengage, not because they deny the threat, but because they feel powerless to respond meaningfully. Continuous exposure to catastrophic narratives without clear, achievable action pathways encourages withdrawal rather than mobilization. Alarmism also interacts with learned helplessness. When outcomes are framed as inevitable, collapse, irreversible damage, runaway feedbacks, individual agency appears irrelevant. If catastrophe is already locked in, adaptation and mitigation feel symbolic rather than substantive. This reduces motivation for incremental but effective actions that actually matter over long timescales. Another effect is temporal narrowing. Emergency framing prioritizes immediate emotional response over long-term planning. People focus on symbolic gestures or dramatic interventions rather than durable systems, infrastructure, governance, maintenance, and gradual decarbonization. The psychology of crisis favors visibility over effectiveness. Alarmism also increases binary thinking. Complex trade-offs, energy density, land use, grid stability, supply chains become morally charged rather than technically evaluated. Disagreement is interpreted as opposition rather than analysis. This polarizes discourse and makes pragmatic compromise more difficult, even when goals are shared. There is also an equity dimension. High-income individuals may respond to alarmism with anxiety and overconsumption of green signaling. Lower-income populations, facing immediate material constraints, may disengage entirely. When climate messaging emphasizes existential threat without acknowledging uneven capacity to respond, it alienates those with the least flexibility. Youth psychology deserves particular attention. Alarmist narratives presented to younger generations, especially without proportional emphasis on adaptation and resilience, can foster chronic anxiety and fatalism. Studies increasingly document climate-related distress that does not correlate with scientific literacy, but with perceived lack of control. This is not an inevitable outcome of climate knowledge, it is a product of how that knowledge is framed. Importantly, none of this implies that minimizing risk is beneficial. Underreaction carries its own costs. The problem is persistent maximal framing, treating all risk as acute, all uncertainty as negligible, and all futures as collapsing. This erodes trust over time. When predicted deadlines pass without the expected collapse, credibility suffers, even if underlying trends remain real. Effective risk communication balances urgency with agency, severity with solvability, and uncertainty with transparency. Alarmism overloads one side of that balance and neglects the other. The psychological result is not sustained engagement, but oscillation between panic and apathy. Segment 5 concludes with a quiet insight. People do not act best when they believe the world is ending. They act best when they believe their actions meaningfully shape outcomes over time. One of the most consistent features of climate alarmism is the treatment of human society as static. In many catastrophic narratives, populations absorb climate stress but do not meaningfully adapt. Infrastructure remains fragile, technologies stagnate, governance fails uniformly, and behavior does not change. This assumption simplifies storytelling, but it contradicts both history and systems analysis. Adaptation is not a future invention. It is already occurring. Coastal defenses are being redesigned, agricultural practices are shifting, building codes are changing, energy systems are diversifying, and water management strategies are evolving. These changes are uneven, imperfect, and often reactive, but they are real. Alarmist framing frequently excludes them because adaptation complicates the narrative of inevitable collapse. From a technical perspective, risk is not solely a function of physical forcing. It is mediated by response capacity. A 1-meter sea level rise has radically different implications depending on urban planning, economic resources, and institutional competence. Yet alarmist projections often present impacts as uniform, implicitly assuming minimal response. There is also a temporal mismatch. Adaptation operates on shorter timescales than climate forcing. Infrastructure can be upgraded in decades. Technologies can diffuse in years. Behavior can change within a generation. Alarmist narratives tend to project climate trajectories forward without projecting societal adjustment forward alongside them, creating an artificially brittle future. Resilience is frequently misunderstood as denial or complacency. In technical terms, resilience is the capacity of a system to absorb disturbance while maintaining function. It does not imply immunity to damage, it implies recoverability and reorganization. Climate alarmism often conflates acknowledging resilience with minimizing harm, discouraging its discussion altogether. Markets and innovation play an uncomfortable role in this tension. Energy transitions, efficiency gains, and substitution effects are often treated as external moral questions rather than endogenous system responses. While markets alone cannot solve climate change, excluding them from analysis exaggerates fragility and underestimates adaptive dynamics. Alarmist narratives also struggle with heterogeneity. Climate impacts are local, not global in experience. Some regions face acute risk, others face manageable change. Some sectors are vulnerable, others benefit. Alarmism tends to homogenize outcomes, producing a global story of decline that does not match regional complexity. This homogenization feeds back into policy design. When collapse is treated as universal, targeted adaptation appears insufficient or unjust. Resources shift toward symbolic global solutions rather than practical local ones. This can delay or crowd out investments that reduce real harm in specific contexts. There is also a psychological cost. When adaptation is excluded, the future appears closed. When resilience is acknowledged, the future reopens, not as safe, but as contingent. Alarmism often resists contingency because it weakens the rhetorical force of inevitability. None of this suggests that adaptation eliminates climate risk. It redistributes it. It buys time. It changes failure modes. Alarmist framing treats adaptation as a footnote, when in reality, it is one of the primary variables determining outcome severity. Segment 6 ends with a reframing. Climate change is not a single global collapse scenario, but a long negotiation between physical systems and social response. Alarmism simplifies that negotiation into a verdict. Technical analysis keeps it open. Energy systems sit at the center of the climate challenge, and they are also where alarmism produces some of its most tangible consequences. When climate change is framed as an immediate existential threat, energy policy often shifts from engineering optimization to moral signaling. The difference matters. Modern civilization runs on energy density, reliability, and scale. Decarbonization is not simply a matter of choosing clean over dirty sources. It is a complex systems problem involving grids, storage, materials, land use, intermittency, and geopolitical supply chains. Alarmist framing tends to flatten these constraints, treating energy transition as a matter of political will rather than physical and economic feasibility. One effect is the compression of transition timelines beyond what infrastructure replacement realistically allows. Power plants, transmission networks, and industrial systems are capital-intensive and long-lived. Rapid forced retirement can increase costs, reduce reliability, and provoke backlash without delivering proportional emissions reductions. Alarmism treats delay as failure, even when pacing is critical to system stability. Another consequence is selective technology favoritism. Solutions that align with symbolic narratives, visible renewables, lifestyle reduction, decentralization, are often elevated, while less emotionally appealing but effective options receive less attention. Nuclear power, grid-scale storage, carbon capture, and transitional fuels are frequently marginalized not on technical grounds, but on narrative compatibility. Alarmist discourse also struggles with trade-off honesty. Every energy system has externalities. Wind and solar require large material inputs and land footprints. Batteries depend on mineral extraction. Grid expansion disrupts communities and ecosystems. Alarmism tends to frame opposition to these impacts as obstruction rather than legitimate constraint, eroding trust and slowing deployment. There's also a global equity dimension. High-income countries can afford redundancy, experimentation, and higher energy costs. Low-income regions often cannot. When alarmist policies assume uniform capacity to absorb cost increases or reliability loss, they risk entrenching inequality while achieving minimal global emissions impact. Moralized framing further distorts incentives. Policies designed to signal urgency may prioritize visibility over effectiveness, mandates that look decisive but shift emissions geographically rather than reducing them. Manufacturing moves, supply chains reroute, accounting improves, but atmospheric outcomes change little. Alarmism celebrates action without always measuring results. From a systems perspective, decarbonization succeeds when it is boring, incremental, and relentless, driven by cost curves, reliability gains, and institutional learning. Alarmism resists this mundanity. It demands transformation on a narrative timeline, not an engineering one. This does not mean urgency is misplaced. It means urgency must be disciplined. When urgency becomes moral absolutism, it discourages compromise, experimentation, and correction. Energy systems punish ideological purity. They reward robustness. Segment 7 leaves a practical insight. The atmosphere responds to tons of CO2 avoided, not to intensity of belief. Alarmism often confuses the two. One of the clearest fingerprints of climate alarmism is the transformation of measurement into milestone. Technical metrics, temperature thresholds, carbon budgets, emissions pathways are increasingly treated not as analytical tools, but as symbolic deadlines that divide history into before and after. This shift subtly but profoundly alters how climate risk is understood. In climate science, thresholds like 1.5 degrees Celsius or 2 degrees Celsius are reference points, not cliff edges. They were chosen to structure comparison, policy discussion, and risk assessment across scenarios. Exceeding them does not trigger a discrete physical state change. Impacts increase in probability and severity, not in binary jumps. Alarmist framing often strips away this continuity, turning reference values into points of no return. Carbon budgets suffer a similar fate. Budgets are accounting constructs based on assumptions about climate sensitivity, feedbacks, and future emissions pathways. They are recalculated as science improves. Alarmism frequently presents them as fixed countdown clocks, implying that once a budget is exceeded, meaningful action becomes pointless. This encourages fatalism precisely when continued mitigation remains valuable. Deadlines amplify this effect. Phrases like "only X years left" compress long-term processes into artificial time horizons. When those deadlines pass without the predicted collapse, public trust erodes, not because the science was wrong, but because the framing promised finality where none existed. Alarmism also encourages single metric fixation. Global average temperature becomes the dominant indicator, overshadowing regional variability, adaptation capacity, and sector-specific impacts. This narrows policy focus and discourages multidimensional optimization. Climate systems are reduced to a scoreboard, and success or failure becomes a matter of crossing lines rather than reducing harm. This fixation feeds into policy performativity. Governments and institutions set highly visible targets, net zero dates, percentage reductions, pledges, without proportional emphasis on enforcement mechanisms, infrastructure readiness, or long-term durability. Targets become reputational assets rather than engineering plans. Alarmism rewards ambition in language more than follow-through in practice. There is also a subtle cognitive effect. Finality framing implies that there's a last chance, after which outcomes are locked in. This contradicts the cumulative nature of climate forcing. Every ton avoided matters regardless of timing. Alarmism inadvertently undermines this truth by implying that late action is equivalent to no action. From a technical standpoint, climate mitigation is a gradient problem, not a threshold problem. Outcomes worsen smoothly, not suddenly. Alarmist narratives obscure this gradient, making climate action feel like a gamble rather than a continuous investment in damage reduction. Segment 8 reframes the issue. Metrics are tools for navigation, not verdicts. When they are treated as existential deadlines, they distort both understanding and strategy. Trust is a slow variable. It accumulates gradually, degrades quietly, and is difficult to restore once lost. Climate alarmism, even when motivated by precaution, places that trust under strain by overpromising certainty in a domain defined by probabilistic reasoning. Scientific credibility rests not on confidence alone, but on calibration, the alignment between stated confidence and actual predictive performance. When climate communication consistently emphasizes worst-case outcomes as if they were likely or imminent, it risks miscalibration. As predicted time horizons pass without dramatic collapse, audiences do not update their understanding of uncertainty. They update their trust. This erosion does not typically produce denial. More often, it produces selective skepticism. People accept that climate change exists but become doubtful of severity claims, timelines, or institutional motives. This skepticism is difficult to distinguish from bad faith rejection and is often treated as such, further hardening divides. Alarmism also narrows the acceptable range of discourse. Scientists who emphasize uncertainty, adaptation, or resilience may be perceived as minimizing risk, even when their analysis is technically sound. This creates a chilling effect on internal debate, which is essential for scientific progress. When caution is socially penalized, confidence inflation becomes normalized. There is a reputational asymmetry at work. Predictions of catastrophe that do not materialize are rarely revisited publicly. Corrections are quiet, headlines are loud. Over time, the public experiences a series of implied failures without corresponding explanations. This pattern trains audiences to discount future warnings, even when they are well supported. Institutional trust is also affected. When climate science becomes tightly coupled with policy advocacy, scientific institutions may be perceived as political actors rather than neutral analysts. This perception, whether fair or not, weakens their authority in pluralistic societies where legitimacy depends on independence. Alarmism can also inadvertently empower counter-narratives. Overstated claims create openings for bad faith actors to discredit entire fields by highlighting inaccuracies or exaggerations. The more absolute the claim, the easier it is to undermine. Precision is protective, absolutism is fragile. The long-term risk is not public panic, it is public disengagement. When trust declines, complex guidance is replaced by heuristics, identity, and ideology. Climate science becomes just another contested narrative, stripped of its special epistemic status. Segment 9 closes with a sober observation. The authority of science depends less on how loudly it warns than on how reliably it distinguishes what is known, what is uncertain, and what is possible. Climate change does not require exaggeration to be serious. The physical signal is clear, the long-term risks are real, and the consequences of inaction are measurable. But alarmism is not the same as urgency. One compresses complexity into fear, the other preserves complexity while still demanding response. A durable climate narrative begins by restoring proportionality. Risks should be communicated in terms of probability distributions, not singular futures. Severe outcomes should be acknowledged without being framed as inevitable. Uncertainty should be treated as a property of complex systems, not as a weakness to be concealed. Such a narrative also treats society as dynamic. Humans adapt, technologies evolve, institutions learn, and failures provoke correction. None of this eliminates climate risk, but it shapes its trajectory. Ignoring adaptation and resilience produces a static world that exists only in models, not in history. A technically honest approach reframes climate change as a management problem, not an apocalypse. Management does not mean minimization. It means continuous assessment, adjustment, and investment. It recognizes that mitigation and adaptation are not moral gestures but operational tasks that succeed through iteration, not declaration. This perspective also restores the value of incremental gains. There is no final deadline after which effort becomes meaningless. Every reduction in emissions lowers cumulative forcing. Every adaptation investment reduces future damage. Alarmism undermines this truth by implying that failure is binary and total. Energy transitions, infrastructure redesign, and social adjustment all proceed at human timescales. They are constrained by physics, capital, and politics. A durable narrative respects those constraints rather than wishing them away. It values robustness over spectacle, reliability over symbolism. Most importantly, a non-alarmist framework protects trust. It invites participation rather than obedience. It allows disagreement without heresy. It makes room for correction without collapse of credibility. Over decades, the timescale climate change actually operates on, trust matters more than intensity. The goal of climate communication is not to terrify, shame, or overwhelm. It is to align understanding with action over the long run. Alarmism may mobilize briefly, but it burns credibility. Precision endures. This documentary ends not with reassurance, and not with despair, but with clarity. Climate change is neither a hoax nor a doomsday clock. It is a persistent, evolving constraint on human systems, one that can be shaped by choices made continuously, not desperately. The future remains open. Not safe. Not doomed. Open.